All right, everyone. Today we're talking about 6.3, which is square root functions. Square root functions. Okay. Our objective for the lesson is to graph and analyze square root functions. All right, we talked a little bit yesterday, if we had I guess we used f of x. We're starting to use function notation a lot more. We talked about graphing parabolas, guys, they're quadratics, okay? And they are, x squared, that'd be the parent function, the simplest function. Well, guys, the inverse to squaring something is square rooting something. So these are inverse functions. We'll talk a lot more about what it means to be inverse functions in the lessons coming up. But I did want to review that before we did this lesson so that when we start talking about inverses, this can be a good baseline for us. We can talk about these two types of functions and relate them in a way that inverses are related. Okay? But today, our goal, not terribly worried about the inverse part, our goal is just to be able to graph and analyze these functions. All right, so square root functions, let's get a quick definition here. Square root functions. Okay, square root functions. If a function contains the square root of a variable, then it is called a square root function. Okay. Talk about the parent function here a little bit, the simplest format. Because the parent function is, of course, f of x equals the square root of x. A graph of this is, because it has a point at 0, 0, I'll talk about why that is here in a minute, but it has a vertex-like point at 0, 0. Guys, apologize for the bell there. Okay, if I did my axes backwards, the bell's got me flustered. There's my y-axis, my x-axis. All right, you can think about the point 1, 1 would be on this. Okay, so the square root of 1 is 1, and then the point 4, 2 is on here as well. Okay, so that is the graph of f of x equals the square root of x. That's the parent function, the simplest format there, guys. If you plug in x, you take the square root of it. So square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. So that's why those points are on there. All right, little bit of notes about this. Guys, the domain, guys, the x values that work, they have to be greater than or equal to 0. Why? Okay, well, as we learned last year, can't take the square root of a negative number. That becomes imaginary. So that's why x has to be greater than 0, so we can take a square root of it. Okay, it has to be a positive number, and it can be 0, so greater than or equal to 0. Guys, the range here is, that's the y values that apply here. In this case, it's going to be greater than or equal to 0. It's only graphed above there. Doesn't go below it. And that's pretty much it. Okay. A little note here about the domain. The domain of a square root function is limited by the values for which the function is defined. And that just goes back to us talking about, why does x have to be greater than or equal to 0 in that first one, okay? Because we can't have a negative number under a square root, okay? This, guys, remember, is just for the parent function. We're going to talk about how do you find domain and range of general square root functions. So let me add a page here. So we got a parent function here, centered at 0, 0, and kind of goes up and to the right from there. So, okay, and don't need to write this down. I want to do it for kind of a highlight here. So if I had this parent function, well, what if I put a -1 out in front of my square root? Okay, well, I'd still have a point at 0, 0. Then I would have points at 1, -1, and 4, -2. Okay, and so that would be the graph if I had an a being negative. It flips it over the x-axis. So if, looking at the parent function, the range was greater than or equal to 0, okay, well, this range has to be less than or equal to 0. So more room. So finding domain and range. Okay. So let's do an example here. What if I had f of x equals the square root of x plus 4? Okay. To find the domain, what you need to do is take what is under the radical, so x plus 4, and you need to limit that. You need to say that that has to be greater than or equal to 0. Again, what is under the radical has to be positive, okay, or 0. And if you solve this inequality, you get that x has to be greater than or equal to -4. Okay, so that is how you find the domain. The range of a function, square root function, okay? Once you have the domain, then you want to find f of that domain limit there. So f of, in this case, -4. Okay, so if we plugged -4 in for x, what do we get? We get the square root of 0, which is 0. So f of -4 is 0. So that is that 0 is the lower limit for our range. Lower limit meaning f of x has to be greater than or equal to 0. So that is finding domain and range of a square root function. Okay, let's do another example of that. Okay, a little more complex example. F of x equals square root. Let's go x plus 6. Let's go outside of the square root. We'll have a plus 2. So again, to find the domain, you are only taking what is under the radical. And you're restricting it that has to be greater than or equal to 0. So you're going to subtract 6. And here we say x has to be greater than or equal to -6. Then, of course, for range, okay, we're going to find f of that domain. Restriction there, -6. F of -6 is, well, -6 plus 6 plus 2. So this is the square root of 0 plus 2, which is 0 plus 2, or 2. Again, this is the lower limit of range. So that's to say that f of x must be greater than or equal to 2. So there's your range, there's your domain. Okay, guys, I'm going to put together a chart for when we're graphing these. I'm going to go ahead and add another page here. That kind of tells you how the graph should change from the parent function. Okay, this chart that I'm going to make is transformations of the parent function. Okay, so that was the most basic one. Of course, there's going to be more complex ones. Okay, so all of the changes that could happen to a square root function can be defined by this: a, h, and k. We can subtract or add numbers inside, we can add and subtract numbers outside, and we can multiply and divide outside. Okay, they can all be defined by this. So what does that h do? Okay, well, h deals with horizontal translations. Okay, h is horizontal translations. So this function is going to move left and right, horizontal, left and right. It's going to move h units, h being a number, h units right if h is greater than 0, if it's positive. It's going to move absolute value of h units left if h is negative or less than 0. Okay, guys, the domain, I know we were just finding domain in a pretty simple manner, but this is a general rule. The domain is x has to be greater than or equal to h. Right? So if h is moving us horizontally, k will do the same thing vertically. So it is vertical translations. All right. So the vertical translation, that function is going to move k units up if k is greater than 0. And it's going to move absolute value k units down if k is less than 0. So very similar to horizontal. It's just moving that graph up or down as many units as k does. All right. And, okay, there's one more thing. Before we talk about the range over here, before we talk about range, I want to talk about a. Because a can change things a little bit. That number out in front of our square root. Okay. A deals with orientation. Okay. And a little bit shape. It can stretch and compress things. But I'm more worried about orientation. Okay. If a is negative, if a is less than 0, that reflects over x-axis. Okay? So, let me go back to the parent. We have an a number that is negative. It's going to flip it down. Okay? Well, how does that impact range? Okay? When we define range, we have to do it with regards to a. If a is greater than 0, the range is greater than or equal to k. If a is less than 0, the range needs to be less than or equal to k. All right? So that is all your transformations of the parent function. All right, let's take a look then. Let's do an example here. I'm going to add another page. Do it back on that previous page. I'm going to scroll a little bit so we're all on the same here. Let's graph f of x equals, let's go square root of x minus 2 plus 5. All right, if we're going to graph this function, okay, notice a is positive. There's no real a value there, nothing in front of the square root. H is positive 2, that's because it's x minus h, so h is positive 2. K is 5. Okay, that means our minimum point, okay, or that vertex-like point, I'm going to put that in parentheses, where the function starts, okay, is hk. It's always hk. So in this case, that is at 2, 5. If I'm graphing this function, I am at 2, 5. That is my minimum point. It's going to go up and to the right from there. That's how we've translated from the parent function. Okay, there is our minimum point. Okay, that's step 1. Step 2, domain and range. Let's define those. Okay, x must be greater than or equal to h, which is 2. F of x must be greater than or equal to k, which is 5. The third step, just like yesterday, is making a t-chart. Okay, I'm going to do that right here. Okay, so don't need to put that minimum point in the middle, just put it up at the top, 2, 5. And we know this is going up and to the right, so let's pick, I want you guys to graph at minimum 3 points, 3 more points. Okay, you put your minimum point there and you get 3 more. So let's do 2, let's do 3 just for fun. Let's skip a couple, 5 and 7. Okay, guys, this is going to be calculator work. Some of the mental math will work out nice, some of it won't. If I'm going to plug in f of 3, guys, that's going to be square root. Using your calculator, it's going to bring up parentheses. You're going to plug in 3 for x minus 2, close those parentheses, add 5. Guys, this ends up being square root 1 plus 5, which is just 6. Okay, so 3, 6 is your next point. Okay, 3, 6 is your next point. And you're going to want to just keep plugging in, 5 and 7 in this case. You guys could go 4, 5 if you wanted. Actually, in fact, I am going to go 4, 5, only because I don't think I have room to get out to 7 there. So let's plug in 4 and 5. Okay, I'll use my eraser. Let's plug in 4 and 5. So I'm going to use my calculator, guys. I'm going to quit doing mental math because I think when I plug in 4, I should end up with a decimal. And you do. It's 6.41. So as I go out to 4, I'm going to be just above 6. And I got a feeling 5 is going to be similar ballpark here. 5 minus 2, and then we're adding 2. Oh, adding 5. Guys, apologize there. I had a knock at the door, so a little fumbling going on there. We got 6.73. Sorry, when we plug in 5, you should get 6.73. So again, just slightly increasing there. Sometimes more useful to plug in additional points, but guys, we got the idea where this thing's heading. Okay, again, minimum, I want you to plug in 3 extra points other than your minimum point. Okay, quick 3-step process there. Yeah, I guess we'll wrap up there. I have a homework assignment for you all. So be sure to get in and take care of that. All right, everyone have a wonderful afternoon. Actually,